Hey guys, last time I left you this exit slip or homework activity. Here are kind of the answers to it. So you can at least kind of check your work, see how you did. I'm not going to go into explaining. If you want to know how to why any of those the way they are, you just rewatch that last video. It tells you how to do all these types of problems. It doesn't do those specific problems, but it does tell you how to do them, or ones like it. All right. As we move forward, we're going to add and subtract polynomials combining like terms. This is essentially what we're doing here. This is not a difficult task. This is one we've been doing all year. It's been something you've done for a lot of years. It's just a little different because we have degrees of higher powers now. We're going to have to combine terms of fourth degrees or fifth degrees or whatever they are. All right. So, for instance, we already know how to do simple things like 2x plus 3x, right? We know that that's going to be 5x because they're like terms. We can combine them together. We add the coefficients 2 plus 3, and we get 5. The only thing that you probably haven't done before, but it's absolutely no different, is if you have, let's say, 2x to the 5th plus 3x to the 5th. Notice they're both like terms. They both have x to the 5th, so we can combine them and make a 5x to the 5th because 2 plus 3 is 5. So it's absolutely the same thing. The only thing you got to look out for is, of course, only combine like terms. Don't combine things that are not like terms. So you wouldn't try to combine 2x to the 5th plus 3x because they're not like terms. So you will not combine them. You only combine them if they have the same variable with the same exponent, right? X to the 5th, x to the 5th, or x and x. But not things with different exponents. Okay, make sure that they are like terms and combine them. Essentially, all it's going to be today. All right. People always freak out when they see parentheses, but don't freak out when you see parentheses. It just means that this is a polynomial. At some point, that's the way it was, and we want to add to that polynomial this polynomial. There's just two polynomials. The parentheses are only there to identify that they were once a family of polynomials. But it doesn't really matter because we're going to mix them up and combine them in terms anyway. Now, this is important, though, that you look at the sign in between them. The sign here is adding. So guess what we're going to do? We're going to add these polynomials together. But remember, we're only going to add like terms. So let's look at the left. Notice, I'm looking at the whole thing, I guess, to begin with. And I'm looking for what is the biggest degree term. Because I'm going to write this answer in standard form at the end of the problem. And I want to make sure that I put the biggest degree first, and then I'll do the smallest degree last. So looking at this whole thing, I notice that the biggest degree I can see is the third degree, right? I've got 2x to the third, and I have a 1x to the third. So the biggest degree I have is x to the third. I've got two of them. I'm going to add them because I'm combining like terms. 2x to the third plus 1x to the third is going to make up 3x to the third because 2 plus 1 is 3. You don't do anything with the exponents because all we're doing is adding like terms. The exponents are there just to identify what's like terms and what's not. So if I have 2x to the thirds and I add 1, I'll have 3x to the thirds. Nothing changes with the exponent. Alright, let's work our way down. Let's keep changing colors here. What's the next biggest degree that you see? Well, if we just had an x to the third, the next biggest would be an x squared. So do I see an x squared? I do. It's right here. Now notice I don't see any other x squared. So there's not any x squareds in the first polynomial. That's fine. But I am adding that 5x squared. So guess what I'm going to do? I'm going to be adding 5x squared down here. That doesn't change because there was no like terms. It didn't combine with anything. It simply stayed the same. But keep in mind that we're adding it. So that's why I have a plus sign. All right. The next biggest degree would be x to the first power. Let's see if I can find any x to the first powers. I can. I have a negative 1x here, and I have a 7x. So I've got two. Guess what I'm doing with them? I'm adding them. So negative x plus 7x, negative 1, basically, plus 7 is positive 6. So that's going to be a plus 6x. And then the last term would be a constant. So I've got a couple of those. I've got this plus 9, and I've got this 4. And guess what I'm doing with this positive 9 and this 4? You guessed it, you're adding them. 9 plus 4 is going to be 13. So plus 13. And there you have it. There's your answer. Nothing tricky about it, really. You just have to identify the pieces that are similar to each other, and then add them together or subtract them. It could be a subtracting problem, but just combine them. Combine your like terms. You don't have to change the exponents at all. You just have to simply add or subtract. Really not too much difficulty in that, I hope. Okay? All right, add or subtract. Obviously here, you've got your two polynomials. Don't sweat the parentheses at all. They're really only there for organization purposes, but we can ignore it. But we have to keep in mind that we're subtracting here, so be very careful about that. Okay? Notice, what are we subtracting? We're subtracting this polynomial, those three terms. All right, well, let's get into the math. All right, look at the whole thing. Let's identify what the biggest degree that we can find. The biggest degree, I think, is x squared, a degree of 2. I've got 2 of them. Now what am I doing with these x squares? I'm subtracting. So what do I have? You can write this off to the side if you want. You have negative 2 minus, that's what we're doing, subtracting, a 1x squared. So I've got negative 2 minus a 1x squared, which would be a negative 3x squared. So a lot of times people will look at just this positive 1x squared and add it to negative 2, but you have to pay attention to the fact that we're not adding in this problem, we are subtracting. So b minus would be a negative 2 minus 1. All right, let's see what else. The next biggest degree, if I just had an x squared, would be x to the first power. I do have an x to the first power, it's over here. But what am I doing with this? I don't have any other x powers to combine it to, or other x terms to combine it with. But I am subtracting, notice, subtracting this negative x. So you might not have any x's on this first term. So you have none in the first group. But you're still subtracting a negative 1x, which obviously, if you're paying attention, would become positive 1x. So this is going to become plus 1x, or plus x. That confuses people sometimes. They think, I see a negative x, I don't see anything to combine it with, let me just bring it down. And they'll write minus x in their answer rather than plus x. But that's incorrect because we are subtracting this negative x. I'll tell you one thing that you can do if that confuses you at the end of this problem. Let me finish the problem and I'll go back and tell you if that confused you, a different way you can kind of look at this. All right, what's next? The next thing I would do is the constants, right? I have a 3 minus a 6. So remember, you have a 3 minus a 6. A positive 3 is positive 6, but I am subtracting them. 3 minus 6 is a negative 3. All right, so combine everything. There's your final answer. All right, now let me backtrack a little bit. If you can do that, you know how to get that. That's fine. You can ignore it for the next 30 seconds or so. But if that confused you, let me tell you another approach. If you're subtracting this polynomial, then go ahead and just distribute this negative to all of those things. Make this a negative x squared, make this a negative 6, and make that a positive x. That way you've already subtracted everything, and now all you have to do is combine it with those terms from the beginning. Okay? But everything's already being subtracted, you've taken care of that negative, now it's essentially just combining like terms. The x squared is a negative 2, a negative 1, make a negative 3x squared. You have that positive x. Again, there's no other like terms. So it's that plus x. Again, we've already taken care of the subtracting by distributing that subtracting sign. And then we see the 3 minus the 6. 3 minus 6 becomes negative 3. It's the same thing. I kind of like this approach because it does the subtracting in the very first step so that you don't have to kind of think about it as you work the problem out. You just sort of have your terms and you combine your like terms. So it's kind of neat. It's kind of easy that way. All right. So here we're doing the same thing. We're adding them. Find your like terms. Add your like terms. So look all along here. It seems what's the biggest degree term that you can find. And if you look carefully, you notice that the biggest degree term is this 16x to the third. Now, I don't see any other x to the thirds. I am adding a 16x to the third, so we're too much. So we're just going to bring it down. There's nothing to combine it with. So it'll be 16x to the third. All right, we'll find any other x. Then, okay, that's the third degree term. Let's see if we can find any x squared terms. I can find a couple. There's one there. There's one there. And guess what we're doing? We're adding them. So I have a negative 36 plus a 6. So negative 36 plus 6 would be negative 30 x squared. All right, continue this. The next biggest term would be x to the first power. So I see I've got a positive 6x here. I don't have any other x terms. I'm adding nothing to that positive 6x, so I'm just going to be bringing it down essentially with the plus 6x. And then I'll add my constants together. I've got a couple of them. Negative 11 plus negative 5. Now keep in mind you're adding a negative. Negative 11 plus negative 5 is essentially negative 11 minus 5. Either way, if you try to use a calculator, you should end up with negative 16. Hopefully you don't need a calculator, but using one's not going to hurt you. Okay? So there you go. Again, all you do here is identify what's similar, right? What are like terms, and add them. That's it. Add or subtract. I'll leave this one for you. Again, a pro tip I would suggest doing is, since you're subtracting, go ahead and subtract everything to begin with. So subtract minus 15x squared, minus 3x, and then minus a negative would make that plus 2. And take that and combine it with those terms. That should be a little easier, in my opinion. But you can do whatever you want to do. All right. Well, that's the warm-up for the next day. I think between now and the time you have class, I'll probably have another exit slip for you to do for these adding and subtracting problems. But that's going to end it for today. So we'll move on. The next thing we have to do is multiply. Multiplying is a little bit trickier than adding and subtracting, that's for sure. We'll take it easy, but that's what we have next. All right? I'll see you in that video. Later.